Assalamualaikum and a very good day to Dr. Azwin. My name is Muhammad Zikri by Abdul Jami, and our group will be presenting on question number 4. So the waveform of a periodic function y equals to fx is given as values in the following table. So the tables are given as x degrees values and also y values. It is given that a1 equals to negative 0.178 and b1 is negative 1.464. So they ask us to find the Fourier series of fx in the standard form up to and including the second harmony. So the given values, which is a1 and b1. So before we can, so this is the general equation before we can obtain these values. So, but the question itself already given the values, so we don't need to use this equation. But this is just for our information. And then next one, we have to form a table starting from x degrees until and it will ending to yr sine 2x. So the reason why we stop at yr cos 2x and also yr sine 2x is because the question itself it says find for a series expansion in standard form up to and including the second harmony. So that is why we table are going to stop at the yr cos 2x also yr sine 2x. And then after we have obtained all of these values, only then we can form the Fourier series equation. So which is fx equals to c naught plus c1 sine in bracket x plus alpha 1 plus with sine c2 sine in bracket 2x plus alpha 2. And the reason why we stop at c2 sine 2x plus alpha 2 is the same reason as I said just now. The question itself asks us to find up to the second harmony. So the rest of the answers will be presented by my friends. So that is all from me, and thank you.
Okay, hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Mohd Arif Syahmi by Sohaimi. So I'll be the one to continue the presentation from my previous friend. So as you can see here, we need this is the equation, the Fourier series equation. We need to find C0 right now. So the formula for C0, C0, is 1.5 A0, and the formula for A0 is 1 over 6 the summation of 12 when r equals to 1 by r. So yr we can get from the table above, that is 34.92. So we just times it with 1 over 6 and we get the answer, and then only we can calculate the C0, that is 1 over 2 A0 that we have been calculated before, and then we just insert it and then we get the answer 2.91. Okay, settle for C0. The next one we have to find C1. C1 is the square root of A1 squared plus B1 squared. So as you can see here, we already get A1 and B1 at the equation, that is negative 0.178 for A1 and negative 1.464 for B1. So we just insert the number at the formula. So square root of that A1 and B1 squared, we get the answer 1.475. And now we have to search, we have to calculate the alpha 1, and the formula for alpha 1 is tan inverse A1 over B1. So again we insert the A1 and B1 at the formula, and finally we got the answer, that is 6.93 degree. That's all from me, thank you.
Okay, now we are going to continue for the solution for the question 4. So after we've done find for the A1 for the C1 and C0 here, so we need to find for the C2. So the reason why we need to find for the C2 sin 2x plus alpha 2 is because the question is asking for us to find the Fourier series of the function fx in the standard form up to and including the second harmonic. So this is the reason why we are going need to find the C2 and also alpha 2. So on how to do it, so to do it, it has the same solution for the A1 and B1. So for the A2, we just multiply 1 over 6 with yr cos 2x. So the total for yr cos 2x is 9.11, and we just multiply it. Then we can get the answer is 1.518. And then we need to find for the b2. So for b2 is 1 over 6 yr c2x. So for yr c2x, we have the total is negative 2.528. So we just multiply it with 1 over 6, and then we can get the answer is negative 0.421. And then from after we have found the answer for the A2 and B2, we can calculate for the C2. So for C2, we just use the same formula with the C1, that is square root A2 square plus B2 square. Just put your numbers inside the formula, and then we can get the answer is equal to 1.575. Okay, we're done with the C2. Now we continue with alpha 2. So for alpha 2, we are going to use A2 and B2. So the equation is tan inverse A2 over B2. Just put the value we have here, and then we can get the answer is negative 74.5 degree. Since we have all of the value for C0, C1, alpha 1, C2, and also alpha 2, we just put it back in our final equation for the functions of the series is this one. You can see. And then the final answer for this question 4 is fx is equal to 2.91 or C0 plus 1.475 C1 sin x plus 6.93 alpha 1 plus with 1.575 C2 since 2x minus 74.5 degree, our alpha 2. So that is our final solution. Okay, and that is all for our group, and thanks for watching.